The present paper introduced a new method for the pronunciation training system. We believe that foreign language learners should know how to adjust their pronunciation, not an accent. We will deliver it into 4 parts to illustrate it. Automatic speech recognition plays a crucial role in facilitating the language learning system. For instance, the top test provider applies an answer system called SpeechRater to score the speaking test part. In this scenario, the development of answer meaning concentrates on scoring user pronunciation. However, could improve the learner's pronunciation through encouraging self-correction by learning to adjust their articulation. To sum up the problems, there are 3 fundamental challenges in this research. The available application in the market only send the scores to learners without giving useful information about why getting the wrong articulation. Therefore, they don't know how to adjust the correct pronunciation by scores or speech signals. Why are vowels important? Vowels are found in every syllable of every word. In phonetics, every vowel can distinguish from the other vowel by categorizing it with 2 properties, the tongue position and the lip shape. Similarly, this is why a photographer asks us to say a word like a vowel E like cheese. We propose a vowel articulation recognition system implementing on smartphones. The system simultaneously analyzes both speech and ultrasonic signal to capture the tongue position and the lip shape. Finally, it can give user instruction on how to adjust their mispronunciation. We take the phonetic rules as a priority task to master monophone vowels. The system has 5 modules. First, linear prediction coding is used to estimate phoneme frequencies to map to the tongue position, height, and backness. Tongue height and backness can be mapped to the vowel diagram. Second, deriving the ultrasonic signal from the Doppler effect examines the lip shape of rounded and unrounded vowels. Finally, we take the phonetic rules as a priority task to map the monophone vowels to distinguish each vowel by tongue and lip. Finally, we use machine learning model to extract features from audio and audio signal in order to recognize vowel. Here is our user interface. User can select which language or vowel to learn. Our pronunciation system can give user instruction on how to adjust their mispronunciation after user practice and record. For example, the feedback of system like "Please move your tongue to the front." We implement a custom-made application into Huawei Mate 9, which generates and records ultrasonic signals for data collection. In our experiment, 20 international students of the Chinese language tested a prototype version over 1 week in our college. The learners are encouraged to be aware of pronunciation by self-adjusting their misplaced articulation. The histogram summarizes their pronunciation accuracies before and after they practice with the system. 90% of the students have their pronunciation accuracy improved, with a noticeable mean accuracy difference of 10.5. The impact of foreign language learning and other types of vowel is significant in future development potential. We aim to explore to generate visual graphic feedback of the wrong articulation to the learner for better understanding and more profound engagement as our prototype. In aspect of system development, we tend to design another module, which could be enabled more practical by extracting the initials, finals, turns, and other speech organs in multiple languages. In conclusion, we designed a pronunciation training system that can visualize monophone vowels mispronunciation and speech articulation according to phonetic rules of tongue position and lip shape. We acquire ultrasonic at 20 kHz to capture 5 gain signal of the lip shape. 90 of the students have a significant improvement in pronunciation after using the system with the feedback of tongue and lip. At last, we propose a new robust system of pronunciation training which implement into a commercial smartphone. That's all. Thank you.